Okay, let's dive into this. We're going to crack open question 8 from an AQA Physics paper, all about specific latent heat. We're not just going to look at the right answers, but really dig into why they're the right answers, straight from the official mark scheme. So, let's get to it.
All right, first things first, we have to understand the investigation itself. What's actually going on here?
So here's the basic idea. A student is trying to figure out the specific latent heat of vaporization for water, how much energy it takes to turn it into a gas. The plan is to boil some water for a set amount of time, that's 600 seconds, and then measure how much mass is lost as steam. Pretty straightforward, right? Now, the exam lays out the student's exact 4-step method. You add the water, measure the starting mass, boil it for 10 minutes, and then measure the mass at the end. Every part of the question that comes next is built on this process, so it's super important to have this clear in your head.
Okay, on to the first question, 8.1. This one is all about picking the right tool for the job, and it's a test of your basic lab skills.
So the question is simple. What should you use to measure the volume of water? It seems like a softball, but what they're really checking is if you know which instruments are designed for measuring volume accurately in a science lab. And according to the mark scheme, you've actually got a few choices here. You could say a measuring cylinder, a measuring jug, a pipette, or a burette. Even though they all have different levels of precision, any one of them would get you the mark because they're all standard pieces of equipment for this task. Let's move on to question 8.2, which is all about spotting the danger in the room. So you're asked to identify a hazard in this experiment. Just think back to the method. We're boiling water. What's the actual source of potential harm here? You've got 3 options to tick: burns, boiling water, or heat-proof gloves. The correct answer, the one you need to tick, is boiling water. And this is a classic exam question. It all hinges on understanding the very specific scientific definition of what a hazard is. It's the source of the harm, not the harm itself. And this is just a perfect example of why using precise language in science is so important. The mark scheme couldn't be clearer. The boiling water is the hazard. A burn is the risk. That's the injury you might get. And heat-proof gloves, that's the precaution you take to stay safe. Getting the difference between hazard, risk, and precaution is absolutely key. All right, we're jumping ahead to question 8.4 now. This gets into the impact of lost heat. And honestly, this is usually the trickiest part of any experiment-based question. It's all about analyzing how real-world problems can affect your results. So the question lays out a real-world problem. Some heat escaped into the room instead of going into the water. And it asks you to explain how this mistake affects the final number you calculate. You have to connect the dots. How does losing heat change the mass? And then how does that change the final calculation? So here's the 3-step logic straight from the mark scheme. First, if heat escapes, that means less energy actually goes into boiling the water, so the change in mass you measure is going to be smaller than it should have been. Why? Well, that's step 2. Simply put, less water actually turned into steam. Now for the final punchline, step 3, when you do the math, energy divided by mass, you're now dividing by a smaller mass. And as you know, dividing by a smaller number gives you a bigger result. So the student's calculated value is going to be greater than the real value. But here's the good news. The mark scheme gives you some flexibility. You don't have to use those exact words. As long as your answer clearly shows you understand that a smaller change in mass leads to a larger calculated value, you'll get the full marks. It's all about showing you get that inverse relationship. Okay, so let's just pull back for a second and look at the big picture. What was this question really testing? See, a question like this is so much more than just remembering the definition of specific latent heat. It's a full workout of your core science skills. It checks if you can pick the right tools, spot hazards, analyze what went wrong, and then explain the knock-on effects of that error. It's really designed to see if you can think like a practical scientist. And that pretty much wraps up our deep dive into question 8. But I'll leave you with a final thought to chew on. How would you make this experiment better? How could you redesign it to stop so much heat from escaping? Maybe think about insulation, putting a lid on it. What could you do to get a more accurate result? Thanks for joining me.